Hello everyone, welcome back to Physics Hub Official. Today we'll talk about the limitations of Bohr's atomic model. Bohr's model was revolutionary for its time, but it has several drawbacks that modern quantum mechanics later fixed. Let's go through them one by one. Only explains hydrogen atom spectrum. Bohr's model can accurately describe the atomic spectrum of hydrogen and other single electron systems, like helium+, lithium-2+, but cannot explain the spectra of atoms having more than one electron. In multi-electron atoms, energy levels and spectral lines do not match Bohr's predictions. Fails to explain fine structure or field effects. Spectral lines, when observed carefully, are often split into finer lines, fine structure, due to electron spin and relativistic effects. Bohr's model cannot account for these details. Similarly, the model fails to explain the splitting of spectral lines seen when atoms are placed in a magnetic field, Zeeman effect, or an electric field, Stark effect. Contradicts Heisenberg's uncertainty principle. Bohr assumed electrons move in fixed circular orbits with known radius and momentum. Modern quantum mechanics, based on Heisenberg's uncertainty principle, shows it's impossible to know both the exact position and momentum of an electron simultaneously. This contradiction makes Bohr's model unrealistic for electron behavior. No explanation for chemical bonding. The Bohr model provides no basis for how or why atoms form chemical bonds or how molecular structures arise. It only discusses isolated electrons in atoms, but most chemical phenomena involve interactions and bonds, which his model does not address. Quantization rule has no justification. Bohr postulated quantized angular momentum, nh by 2 pi, but could not justify why only those orbits are allowed. The rule of quantization was introduced without explanation or mathematical foundation from basic principles. Ignores wave nature of electrons. Later developments showed that electrons exhibit wave-like properties, as proposed by de Broglie. Bohr's model treats electrons purely as particles, ignoring their wave behavior, which is critical for accurately describing electron positions and energies in atoms. Cannot explain intensities of spectral lines. Bohr's model predicts that spectral lines exist. It cannot explain why some lines appear bright and others faint. In real spectra, intensities vary, but Bohr's model offers no explanation. So, in summary, Bohr's atomic model was a major step forward. It explained hydrogen spectrum beautifully. But it had serious limitations. It failed for multi-electron atoms, ignored fine details, and contradicted modern principles like the uncertainty principle. These drawbacks eventually led to the quantum mechanical model of the atom, which explains atomic structure and spectra much more accurately using orbitals, wave functions, and probability. Thank you for watching, and keep exploring the fascinating world of physics.